That's a long time to record. All right, so.
So I just have pulled up the entire spreadsheet that you sent us from yesterday. That's where we should start. Yep.
Yeah, so, all right, so let's open up, Let me share my screen here. Okay, so this is so today's lecture, even though it's chapter 6, is really a continuation of what we did yesterday with chapter 25. I don't know why in the book they thought it was good to separate those two chapters by 19. That doesn't make any sense to me because they're very related. Okay, so just as a reminder, now actually let me say something before we get going on, because I meant to mention this yesterday, okay? So we've got our sum is 1.55. And let's pretend, just for fun, you can do this if you wanted. Let's pretend my alpha was 25%, which is kind of ridiculous. But let's pretend for a minute.
Yeah, I did it before.
Oh, sorry.
Over here or to the left?
I tried to, so the problem is, there we go. I'm trying to make this so that you can see the video. This doesn't have a very long cable, so I can't disconnect it. But anyway. Okay, so if my alpha was 25% and I got a p-value of 21%, in that case, what would I say here? If my alpha was 0.25, which in this case I would reject. I would reject the null, okay? And my conclusion would be there is evidence of discrimination, right? Okay. So let's pretend for a moment that my alpha, so we're going to say, I mean, we've got a 25% chance of being wrong, which is kind of not very good, right? But let's pretend that this was the case, okay? Now, my question to you, okay, so we would say there is evidence of discrimination, but is it the men that are being discriminated against, or is it the women? Okay.
Well, this they determined that there is? Oh.
Because that would be the next question, right? Because all we've said is...
You changed the results, yeah.
We've changed our alpha so that we can do this, okay? Okay, so the idea here, let me go back here for a minute and just remind you what we're looking at. Stop sharing. Okay? Okay, so I really wish we could move this. Anyway, I'll just write over here, and I'm going to turn up this light. Okay? So remember with the chi-square distribution, okay, it normally looks like this. Technically, ours actually looks like this, right? Because we've got degrees of freedom equal to 1. Okay? Now, if I get a sum close to 0, what does that indicate? That it would be independent, right? And if I get a value out here, that would indicate that it's not independent, right? Correct? And remember, when we're doing this, we're talking about a sum, right? Okay? So the question might be, where is the discrimination happening? Because right now we just said there's discrimination, but we didn't say if it was the women or the men, right? Okay? So the idea here is when you're looking at your table, okay, the bigger my sum gets, then it gets out more in detail, right? Does that make sense? Okay. Now, let's go back to my spreadsheet for a minute.
There's actually a Khan Academy video that explains that quite well.
Oh.
FYI, I found it yesterday.
Oh. Okay. So let's talk about this. 1.55. Which of these 4 cells here contributes most to that sum? The female admit, right? Okay, that's the biggest one. Okay, so let's look and see what's happening. We expected that 23.5 females should have been admitted, but only 20 got admitted, right? So what happened there? This is extra credit on your quiz.
3 females and 1 that was pregnant.
So fewer,
Hey, you guys,
Females.
2 minutes to hand in the homework online.
oh yeah, by the way,
Just
sorry,
2 minutes.
I meant to say that.
I just
I hate this computer, holy fuck.
So make sure you do that, sorry.
Yeah, turn in your homework now, sorry, here, I'll give you, just do it in 2 minutes.
Sorry, I'm doing it on my phone because my computer just crashed.
Oh, nice. Okay, I meant to say that at the end of the quiz, I forgot. Okay, so fewer females were admitted than expected, right? So that would tend to say that women are being discriminated against, right? Would you agree with that?
But yeah, obviously.
Okay,
But then-
what's the next biggest number? The males, the 0.405 here, right? So I'll put that in a different color. Okay, now let's see what happened with the males. We would have expected only 31.5 males to be admitted, but in fact, 35 were being admitted. What happened with the males? More males were admitted than expected. Okay? So the fact of the matter is, and that's what the point I want to make, okay? Your conclusion that we ended with yesterday, we just said, well, in this case, we changed our alpha so that we could say this, but there is evidence of discrimination, but you couldn't say if it was the males or the females being discriminated against, okay? Now we can look and we can say, yes, it looks like fewer females were admitted. It looks like females are getting the raw end of the deal and males are getting the benefits, right? Does that make sense? Okay. Now let's change our alpha back to what we should know, okay? So now our alpha is 0.05. We would not reject the null. Do not reject the null. And there's not enough evidence of discrimination. Now I don't need to worry because we said there's not evidence of discrimination. Okay? Now let's go back here because let's talk a little bit about some interesting things. Okay? Now, first of all, we've got 2 women here, right? Women. I usually say this phrase more often than I have this semester. The Mark Twain phrase. Do you guys remember the Mark Twain phrase? Who's Mark Twain?
I don't like that kind of music.
Oh my gosh.
You know that.
I got you. He gets me.
What are you talking about?
We're just talking about Shania Twain.
Oh, Shania Twain? Oh,
We're just being goofy. I'm just still upset that I put a minus sign instead of a multiply sign in my chart, so I got a 5 instead of getting 100%. So I got the wrong numbers.
all right, anyway. There are lies, damn lies, and statistics, right? You've all heard that phrase? That was Mark Twain, okay? So women, it looks here, as we're looking at our data here, that males have a 10% higher admit rate than the females, right? But yet we say there's not enough evidence. How can 10% not be not enough evidence of discrimination? Doesn't it make you want to file a lawsuit, Sandra? Okay?
Look how small that sample size is, though.
It's 140. It's better than the stuff you've been doing, right? Okay? So, you know what happened was, and I think I mentioned this yesterday, this happened at the University of California, Berkeley. So here's what happened. Berkeley actually had 6 colleges, and they went through this little exercise that we're about to do right now. So here's what I'm going to do. I'm going to copy this table, and I'm going to open up a new sheet, and I'm going to paste it over here, and I'm going to erase
You
this.
observe males, females, that's what we're talking.
Well, we're just copying a blank table, really. Okay, so they said, well, you know what? It must be the engineering department. The engineering department against women because we know that there are lots more men than women. So here's what we're going to do. We are going to go to the engineering department and we're going to say, hey, give us your admission numbers by gender, and we want to see if you guys are discriminating. So they did. So here's what happened, okay? They found that 29 males were admitted and 31 were denied, okay? What would be the admit rate? How would you figure that out, Chandler? What would be the admission rate for men? You need to add them up, right, to get the total. So 60 men applied, right? And the admission rate would be?
He said 29.
29, I was talking to Chandler.
No, I'm saying he did say that.
Oh, yeah, I didn't hear him because you were talking too loud. Okay, so that would shows 48% were admitted. Okay, so let's check out the women. The women, we had 11 women were admitted, 9 were denied, for a total of 20 women. What's the admission rate, Aaron? 11 divided by 20. Are the women being discriminated against?
No.
No, who's being discriminated against? The men. Okay. Oh, well, okay, so it's not the engineering department. And in fact, they're actually favoring women by admitting more. Okay, well, it must be. Here's what we're going to do. We're going to copy this table. We're going to paste it. We're going to erase all these numbers. And we're going to say, well, let's check out the English department. It must be the English department, right?
Yeah, it might keep showing up with the stuff.
And that person,
How do you make a table?
Yeah, because whenever I go up there and go make table, and then all of a sudden it turns blue. Like,
Okay, here, watch this.
I don't even touch it.
Okay, watch this. Just type in English, admit, deny, males, females. Highlight all these cells just like that.
I like it, and then I go to insert.
And then you go to click on this right here and you put all borders.
Okay.
Just like I showed yesterday.
Yeah, so that's pretty.
And apparently you didn't watch that video very closely. Ah, you're like, one time was enough. I don't want to go through that nightmare again. Okay? All right. So anyway, they went to the English department and here's what they found. They found that 4 males were admitted, 16 were denied, for a total of 20% admission. And they found out that 11 females were admitted, 29 were denied, for an admission rate of 27.5%.
So,
Who's being discriminated against? Men. So in both cases, the men have a lower admission rate than the women. But yet, it looks like the men have a better admission rate than the women when you look at the entire college. Isn't that weird? Okay? So this is an example of what we call Simpsons Paradox. Okay? Okay, Simpsons Paradox basically says that when you have unequally sized groups, the associations can reverse, which is exactly what happened in this case. It should be the men filing the lawsuit. Now, when we talk about unequally sized groups, how big is the engineering department as far as number of people who apply? We've got 80 students, right? And how big is the English department? 60, okay? So you can see the 80 versus the 60, the engineering department, and plus you've got 60 versus 20, right? Okay? So you can see that the engineering department is so large that when you combine everything together, it looks like the males have it better, when in fact, the females have it better by percentage.
How do you
Okay?
explain that to the layperson? Like, this is People don't think this way.
I know, that's why they filed a law, they actually filed, the women filed a lawsuit at the University of California at Berkeley saying, because they
So
looked
how
at the
is it
overall
explained
numbers
in
and
the
they said
court
the
of
males.
law so that people understand it?
Well, that's a good question. They're all a bunch of lawyers. Get a mathematician, okay? Tell them to take my statistics class. Watch my video, okay? So, yeah, at any rate, so this is an example of what we call Simpsons Paradox. The associations can actually reverse. And in fact, here's what's funny about Cal Berkeley, okay? In the engineering department, this is what happened. The women had a higher admission rate than the men. In the education department, that was dominated by women, right? So they wanted to have more men in, so the men actually had a higher admission rate. In the nursing department, also dominated by women, the men had a higher admission rate. In other departments that were dominated by men, the women had higher. So there was discrimination going on, but it was in reverse. They were trying to have men in women-dominated fields and women in men-dominated fields. They were doing what they were doing, but because of the unequally sized groups, when you combine them together, it looked like the women had it worse. You guys are stunned silent here.
Like,
Sounds like Berkeley, like.
it's hard to understand.
It's hard to understand. But you can see that, right? This is why we talk about lies, damn lies, and statistics. It looks like the men have it better, and the men actually have it worse.
Well, this kind of seems like just a freakonomics thing. Like you
Yeah,
can
it
make the
is.
state to say whatever you want it to say.
But this is the truth, right?
I don't know, I bet there could be a podcast on this whole thing and they would make it look different. Like this kind of thinking just is way beyond what I'm like there about. But I'll.
Does it make sense now? Okay.
Enough to pass the class.
Enough to pass the class.
That's Aaron's like.
Yeah.
Okay. Well, gosh, I thought that was going to take a little longer. So we've got 15 minutes left.
So how do we, okay, so how is
So
this
it's question and
applied?
answer time.
How will this be applied in a question for us? Simpsons Paradox, like how could we expect it?
Do all the chapter 6 homework and you'll find out.
All of chapter 6, okay.
To chapter 6, so we went from 25 to chapter 6, but yes, yeah. So the idea here is we're going to calculate the combined, and then we're going to calculate the groups separately, and we're going to see if there's a paradox. And this is an example of a paradox. Okay? Question?
So here, apply to the M&Ms, I should put like plain M&Ms in famous M&Ms. Should I do that again?
So you guys are going to make your own table, and how many colors are there in M&Ms? 6, right? 6 colors. Now, by the way, oh, here's a good question for you. You can't leave, Chandler.
Yeah, he has to go, have fun teaching Health 1100, dude.
Okay, well, watch the video. You're going to miss out. Okay.
Just stop it right now.
So here's the funny thing that I was just going to mention here. Okay, in fact, let's just do this really quick because this is going to come up. Okay, so you're going to have red, blue, green, yellow, orange, and brown. Aren't those the colors of your M&Ms?
Yes.
Okay. And you're probably, what kind of a graph do you think would be useful to use?
Well, you could do a pie graph and the
Pie graph.
bar chart.
But here's what I'm going to say, 12, 15, 20, 25, 30, 40. Okay, I just made up a bunch of numbers, but you'll use actual numbers. But here's what's funny with the pie graph. Do you guys remember how to do that?
Yeah.
Insert,
Choose the pie.
choose the pie.
We even figured out how to make it so that each section of the pie is the same color as the M&M.
Ah, that's what I was just going for. Are we going to do a 3D pie graph?
No.
No, only if you want to fail this class. Okay? But is the green green?
No.
The green is gray. How do you change that? Because every semester students say, they don't match.
Go to the paint.
So here's how you do it.
Oh,
Double click, sorry, and then click. So the gray I want to be green, right? So I've got the gray clicked. You click on your paint bucket, change the fill, and your color, you can change it to green. Okay? Oh, yellow is yellow. How about that? Is blue?
I can
No,
tell.
blue.
Brown is green, I know that. Okay, how do you change that, Sandra?
So you can,
Go to the paint. So so the first time you click it though, it's gonna click the whole chart, right?
yeah, just leave it fine.
Then you have to click it again. So now it's only the green selected. Go to the
Where it
paint,
said brown.
change the green to brown, which is more colors. Oh, there we go. Now we're getting into brown. Okay. There you go.
You're red.
My red is blue. I think that's the red, right? I want to change that to red. Do you know how to do it? Dalton? Double click. Click the paint bucket. Choose red. The red is now red. The blue is orange or something. What color is that? Yellow, I think it is. No, isn't the yellow yellow? Oh, this is the orange. This should be blue, right?
Yep.
This is orange. Oh, that's funny, they swapped them. Orange. Okay. Well, that doesn't look orange. The yellow doesn't look very yellow. We're going to make that look really yellow. There we go. Okay. And these are your plain M and M's. Okay? So you know how to do that.
Yeah.
Are you going to ace by project, Dalton?
So,
He's like,
No answers, it's just a fingers crossed. All right.
all I know is my whole group's here. So.
Okay.
what about the other people who doesn't have to?
Hopefully they watched the video, right?
Yeah, oh,
This might be our last video. We'll see. I know we can record me. The question is, can I record the screen? I don't know.
So for the review, you're gonna try. You should practice it ahead of time, and then so that, like, it might
Well, I
work.
did, and it didn't work. That's why.
Okay.
Yes.
no, last lesson.
Do we need a bar graph for this, or we just it?
Well, what do you think? What's better, for a pie graph or a bar graph for this?
Well, I thought the bar graph was interesting to compare side by side with the peanut and the M and the plain distribution one.
Doing both.
I mean, you could do either, but I think the pie graph would be better, right?
It's better visual.
Why is the pie graph better than the bar graph?
They're color coded.
It's better visual.
And it looks.
Well, better visual, that doesn't tell me why,
Inside
though.
the bag.
This is all adds up to 100.
Because it adds up to 100%. This is a whole bag, right? So you got parts of the whole. So pie graph is better for parts of the whole.
But if you want to compare like the color distribution in plain versus the peanut, I think that a bar graph is better because you can put the two sides together.
If you want to do a bar graph, you can.
What if we do both? Is that okay?
Both of them.
Because she already has both done.
Wait,
One graphs can't hurt, right?
You guys are the statistician. You can choose what you want to do.
okay.
Every graph.
In that case, I want to give myself 100%.
Well, it doesn't mean you'll get 100%. You can do what you want to do. It's your study, right? All right. What other questions do you have? So you know what, here's the one concern. So Monday and Wednesday and maybe Tuesday, we might run out of time. We might have time Tuesday, okay? These quizzes up to now, I'm going to say have been very easy because, well, except for the one quiz where there were two choices, right? But you only have one choice. You always know which equation you're going to use. And the problem is on the test, I'm going to mix everything up. And you're going to be like, oh, which one am I supposed to use? And I'll be like, that's what we were going over. You're the statistician.
Well, that's the reason.
And that's why this last test is going to be hard because now,
That's why I'm spending the entire day in the testing center, and I'm going to write down every single thing for that question and hope that it just is.
well, if you do that, then I'm going to say you don't know what you're doing and you're going to get it wrong. Okay?
Well, can
You need to know which is the right answer, not just, oh, I'm gonna do it all, and then hopefully he reads the right answer and ignores
What
all
if
the
we
wrong
do it all,
answers.
and then we just erase what we find out was the wrong ones, and then we get right?
Yeah, you
Alright,
can do that, but
chill.
erase, but hope you erase the correct parts and leave the bad parts, whatever. Erase the bad parts and leave the good.
I would be really interested in like problems that have just where the whole exercise is choosing the correct formula.
I know, that's what we're gonna do on Monday.
Oh,
We've got 5 minutes and I don't know if we can do, I could show you.
Like, do you have sheets of questions like that?
I have
mean, know,
sheets of
I'd read the whole
questions.
textbook again, but
Yeah, in fact, if you want, I'll post one this weekend
Well, thank you.
Yeah.
and you can look, but it doesn't have any answers.
Yeah, that's cool.
but maybe we can do it and then you
So
can tell us
here's another
on
problem.
Monday.
This is a spreadsheet I use for my Math 2040 class, and so there are some, most of the questions are for you can handle, but there are some that are like, for example, dependent. Remember, we didn't cover the dependent paired sample. So what I would like you to do is be able to identify that and say, I didn't learn that in this class, but I know it's dependent.
Okay.
Okay, for the last 11 minutes, can you make a list
11
of
minutes?
all the types
I've only got
well,
5.
10 minutes.
5.
Okay, for the, I must be on. Can you make a list of each type of problem that we should know how to identify and what their names are?
Yeah, I did that already, the outline. Remember the outline I posted earlier? Here, I'll show you where it is.
Outline.
So you go to-
I'm seriously, I'm not trying to say,
What outline?
I'm not trying to be rude or anything, I just really,
So do you remember the outline I posted?
where is it at?
Yeah, what outline?
If you just show us and show us.
Did I not post it?
No, you only gave us like the T-chart and then the chart from yesterday.
There's a project.
Huh, maybe I didn't post it. I swear I did.
Trust me, I looked
Here,
at
I'll
stuff.
post it right now.
Maybe today,
This is hypothesis. I could have sworn I posted this. I should. We went over this in
That's fine.
class.
I just would like to have that to practice.
How about we use the remaining 4 minutes of class to figure out what we're doing for a group project?
Yeah, you can do that. You can do whatever you want. But let me just, here, I'm gonna do this.
Well, my group's here, that's the reason why. Last time without going over.
So this will use each type of problem we should be able to identify.
This is driving me crazy.
I'd be crazy.
Britney Spears makes me feel old. Who else makes me feel old? I think there's the, they're pulling 22 something about like 8 or 9 years.
Oh, that's a long time. Denied. Okay, I'll do it, but I can't do it from this computer apparently. I will post that. I will also post
Okay, and it's called overview.
hypothesis test outline. We went over it in class. I could have sworn I posted it, but I don't see it, so.
I mean, I know there's, okay, you did do hypothesis test.
Yeah, that outline is what it is. I usually post it, but
And
apparently I
then you
forgot.
told us there are 5 qualitative formulas and 2 quantitative formulas on that outline. When you said put the correct test.
Yeah, it's on your formula sheet. Do you still have your formula sheet?
Yeah.
They're all right here.
My computer finally rebooted.
So, anyway. Shall I stop the recording?
Yes, please. Yeah, I'm gonna call.
Or do you want to ask me any more questions? Okay. All right, I'm going to stop.
The only question I had, I figured out right at the beginning.
Oh, you did?
I just need an